Hi guys, This is Vishal Sharma back with another edition of CE Live, and this time around, we have three guests that I'd like to introduce before we kick off the details of the show. As I announced, we have Hashim Prosev from Neotel in South Africa. We have Larry Samberg coming to us from Boston. All of you in the Carrier Ethernet group at least know Larry and Hashim pretty well. And we have Pablo Valpardo from Alcatel-Lucent in France, right? Pablo, where are you based?
Actually, I'm based in Italy.
I'm sorry, yeah. So Pablo is in Italy, and you have me right here in California. It's a cloudy day here today, so not as sunny as we usually have it. So guys, before I kick it off, just a few couple of announcements. This is all live, so anything can happen at any time. So if by chance one of us conks out, please just log back in again after a few minutes. I am actually logged in on two machines, so if one of my machine conks out, I'm at least able to continue the broadcast live on my other machine with about a 30-second delay. So that's the thing. If everything conks out, then a note to the viewers that they can just come back in again on the same link that they were on within a few minutes. 5 to 6 minutes. So hopefully we can reboot everything and get back on. So, and a few points of logistics. So the way I'm going to do it is I'm going to discuss a few of the things that were topical in the Carrier Ethernet group, which I thought are really interesting to talk about in this video. But I'm actually going to do a screen share with you guys so you can actually see the mind map that I've put together that captures sort of the most important discussions of the last 2 weeks. And that's right here. This mind map, I'll make that available to you all, right after the show. And let me just close off. Sorry. Okay. So this is the mind map. As you can see, there's a lot of different technology areas that were discussed in the group. Obviously, we cannot get into all of them, but I want to give you a quick overview of the areas we touched. So there's business and network strategy, which I'm going to talk about in more detail. Particularly, I'll talk about some thoughts about new ideas that telcos should be looking at and something that's happening in core standardization in the UC area. There were a lot of interesting discussion on network architecture and design, and in particular, we'll talk about something that Hashim brought up regarding MAC address, MAC addresses in a VPLS-based service environment. Obviously, no weekly discussion of the group is complete without SDN and NFV, and there were lots of interesting thoughts there where people posted about what providers should be doing about SDN and NFV, what service agility means, a lot of initiatives from different operators, SK Telecom, Korea Telecom, Deutsche Telekom, and so forth, and also a number of different vendors. There were some interesting discussions about data center design, and there's a nice white paper that was posted by Mark Abolifa that you should probably go take a look at. And then there was, of course, talk about 5 cells in small G and mobile backhaul. And Bo Gowan of Sienna posted a nice article on the future of backhaul that's actually worth looking at. Then there was, of course, a lot of talk about net neutrality, which we will go into a little bit of detail here. And finally, there's a ton of industry goings on that are all listed here that you can look at leisure. In particular, there was this talk on intellectual property and the Internet of Things. I'm going to talk a little bit about the Internet of Things as it relates to operators. And there's going to be a separate video that we are making on this, and also making the entire discussion available as a video on YouTube, which I'll announce just in a couple of days. So diving into the key areas. Now, because of the fact that Hashim, there's a risk that we might lose him, what I'm going to do is I'm going to reverse the agenda, and which is why I haven't posted an agenda, and go and dive into Hashim's problem first, and then come back and talk about the business strategy and the net neutrality and other items. And then we'll go talk about sort of traffic management with Larry, and the important question that Pablo brought up, which is what happens to Carrier Ethernet as a technology with virtualization. And of course, in all of this, you are allowed to ask questions. I mean, I will invite of course, the guests to chip in with their viewpoints, and all of you are allowed to ask questions. Now, where do you ask questions? That's another good point of logistics. So let me quickly do a screen share and show you that. The best place to ask questions is the actual discussion on LinkedIn. So we've actually got a post out, which is in the manager's choice, very first post today, which announces this hangout. And right below that, Pablo has already kind of, oh, sorry, is this the previous one? No. Oh, I haven't updated it. So Pablo has already rolled the boat by putting his question there, and any attendees are welcome to add their questions kind of to the list, and we'll periodically be checking that. But it becomes a common repository of all the questions that we want. So we'll be checking that, and as we see your questions, we'll try and answer them as far, in line with what we are discussing. But towards the end, we'll keep a little bit of time for Q&A if the attendees want to have a Q&A or want to ask us something. So this is just a point to note. I'm sorry, I didn't press the present to everyone key. So guys, one other point, anytime you present, I don't know if as a guest you have that option, but as a originator, I always have to present, click the present to everyone key, otherwise I think the attendees don't see my screen. So once again, guys, this is where our discussion is related to this hangout, and the questions are to be put here so that it's a common repository of everything, and we know that all the questions are coming in one place. So right after that, let me dive into a meaty problem that Hashim brought up, which is again in our mind map. Right here, and it's outlined in red right here, which is, Hashim, I'll let you kind of articulate the problem, and then we'll talk a little bit about what the motivation was, and what you kind of did about considerations for the VPLS design problem that you were actually looking at, and maybe a few main takeaways that you've arrived at so far. I know this is a work in progress, so we'll hear more about it as it goes. So why don't you dive in, Hashim, and I'm going to stop my screen share, and you can talk about what the problem is and the considerations, how it came about.
Yeah, thank you, Vishal. Good day to everybody, all the colleagues. So I think the short answer to how this all came about is actually quite easy: customers. And our customers are quite important from an engineering perspective, and I'll share why. Customers is always the one that actually pushing us as an engineering business. I mean, we all experience this in our companies. They drive us to do new and quite sometimes challenging things to our networks to satisfy their requirements. So in our environment, there's a lot of customer pressure to solve some of the problems that our customers are facing. And Neotel is one of the innovators in carrier Ethernet in South Africa. So we quite often get the challenging requests from our customers quite early on. So VPLS in our environment is a response to solve a particular problem for our customers. Number one is that in our current portfolio, we've got quite a few point-to-point offerings. And to try and reduce the price point that these customers are buying these services on, our product and innovations team is looking at obviously a multi-point based solution that could bring that cost point down. So the first thing is that we have to consider that the VPLS solution is not a all-encompassing solution for every customer out there. And the starting point for my VPLS journey exactly the so in terms of these segments, I believe that our target should be, especially in South Africa, we're looking at data center interconnect, which is a huge potential market for multi-point based services. And what we also find in South Africa is logistics and distribution in the retail space. So we have these distribution centers for our retail companies, our retail customers around South Africa that needs these multi-point connections, to update stock and to share the status of various distribution houses and so forth. So we found that data center interconnect, retail distribution and logistics houses, as well as our small medium enterprise customers are coming to us with these requirements. They more come to us because they don't want the complexity of sort of layer 3 routing, and they generally only have a few sites that require connections. So we felt that these three segments are the main sort of target segments for our VPLS portfolio. Now saying that is that that is actually the starting point, in my opinion, in terms of doing VPLS design for your network. Because if you understood exactly who the target is, it will give you an idea of how to actually scale this service. What size do you need to make it? How big does it need to be? And once you have your hand on understanding who the targets are, it definitely gives impetus into understanding what you need to be building from a VPLS base. Now, where I am at the moment in our journey is that we obviously going through the service design process, and one of the key questions that's coming up is how much MAC addresses should we allow in a VPLS instance, in a VPLS service? And this is a difficult question to answer, just off the cuff. And obviously we have to go to the drawing board to understand our targets. More importantly, we have to look at the network, right? And
so Hashim, just a quick question. When you say a VPLS service, in your case, it's equivalent to a VPLS instance. Is that how we should understand it? Because when I originally read the question, I thought that you maybe are talking about different services running on a common VPLS instance, but it seems that you're actually equating a VPLS instance to a VPLS service. So I was just making sure that we all understand that, especially for the viewers that are there and people who might be viewing it later.
Yeah, so essentially in our, we have a VPLS instance is a single multi-point EVC. So it could be a single customer VPLS service. And this is how we obviously provision it and designing it on the network at the moment. So it's a single, it can be classified as a single multi-point EVC. Now, just one of the factors that has come to mind in terms of considerations is that we have to understand what is the current capabilities of the network in order to put the service on your network. And two main things come to mind. First thing is that I find in South African market, if you have a multi-services network, so you have a common converged network, and this network, specifically the nodes, whether they are PE nodes, if they are used to deliver other services, layer 3 VPN, voice, internet services, and you are now adding or preparing it to add VPLS, you are significantly constrained generally in your capabilities, in how big you can get and how the size of your VPLS instances. And this is what we experienced on our side. I mean, we run a converged network where we have a multi-services device that generally creates all types of services for our customers. And obviously this was one of the biggest factors that we had to take into account when looking at how much MAC addresses can we support on the device and how big the VPLS instance need to be. Okay. Obviously, we've got a lot of other considerations in terms of our control plane. Do we use LDP? Do we use BGP, auto discovery? There's some other models as well for hierarchical VPLS and so forth. So these considerations are there, but has to be taken into account in terms of what you currently have as a network. If you are fortunate to be of those who have a choice to implement what I could consider as a purpose-built VPLS network. For example, we have seen this with some of our competitors is that they actually deploy equipment purposefully for the VPLS or multi-point services. So this device does not offer L3 services, internet, and so forth. It only offers multi-point business Ethernet services. So obviously the capabilities of scale is quite significant to a provider or carrier that's running some sort of multi-services edge. So this is the two key considerations when designing VPLS.
So Hashim, one question. When people are building these purpose-built VPLS networks, in a sense you're building a parallel network. I mean, or you're directing all of the business traffic to that VPLS network and taking it off of your sort of regular L3 internet network.
Yes, yes. This is what we've seen. So essentially, at the carrier's local presence, or the carrier's POP, you would have equipment that will serve L3 services, and you'll have equipment that will serve L2 business services. And depending on what the customer wants, at the last mile POP, the interconnect will be made to the various type of kit. So if the customer wanted L3 services, they will basically connect him to the L3, call it node, or the services edge that could deliver that service. And if you wanted VPLS, you would have an interconnect to the VPLS node. This is what we find in the industry. And obviously there's a significant cost component to that. I mean, you'll have to build, as you said, a parallel network that's reaching most of the POPs that you have in your network. I mean, it probably won't be at every POP or available at every POP because it's just too cost prohibitive. So they might have concentrated it to a certain location, a certain metropolitan area, and so forth. But
Hashim, are you able to characterize the kind of customer edge device that your customers are using? Because I think that bears heavily on your question. If your customers are using routers to connect into the VPLS network at the edge of their device, then you really only need a very small number of MAC addresses. And if they're using switches, then the number could be a lot larger.
Absolutely, absolutely, Larry. But this is true. There is a bearing on the impact of your design on what the customers are actually connecting to the service. But if you are moving towards VPLS type service, you have to be open to allow a customer using a routed device on your multi-point service, as well as switching devices or bridges into your VPLS instance. And this is why I believe if you nail down the exact target segments and the value proposition to those target segments at the beginning with your product team, you can come up with an acceptable design, an acceptable service design, and model for your VPLS service. So that's true, definitely true. But in designing this type of service, you have to have the capability to deliver to your customer either option at their choice. So that's true.
Okay,
that's
okay,
true.
great. And then you had also mentioned that you might want to talk about a couple of takeaways. So are these the takeaways? I mean, these were the design considerations we learned, that identify the customer base, look at the end equipment that they're going to be using, think about whether you are going to have maybe a common network, a separate network, although that can be very, very, that can be a huge another exercise. And then and beyond that, the specific problem that we were talking about in the group was, how do we divide the MAC addresses across these services? So obviously that's a computation you're still working on. So is there any insights on that, or any other takeaways that that you have, Hashim, that we should talk about here?
Yeah, well, essentially the practice that we followed was to understand exactly a model where we considered all the network components that makes up, or that could end up being participating in the VPLS instance. So we currently, there's not many networks that I've worked on that actually have a common platform for all types of services. Sure. Right? You generally have a mix of one or two vendors, and in those vendor portfolios, you might have 1 or 2 or even 3 platforms in that vendor portfolio, depending on the metropolitan area, how big the pop is, how many customers you need to serve in a particular area. So at first choice, we had to obviously understand the maximum capabilities of all the platforms that's envisioned to participate in the VPLS instance, and then work back, understand what available resource pool we have on these devices, taking into account we are currently serving other customers on them with other services. So we have to understand what's the current delta, what's the capabilities of the box that we have at the moment on its current load, and then work back to understand what is left for use, essentially, in terms of resources, specifically the MAC address table. And they fluctuate quite significantly between the single vendor, but different platforms. From the exercise, they could fluctuate up to 10 times. So you have a particular chassis that support 96,000 MAC addresses, and then you have the next platform supporting 20 or 2 million MAC addresses. So at the end of the day, you actually have to work, and you're limited to using and designing a service based on the lowest common denominator, the lowest common platform that's participating in your VPLS instance. And this is sometimes not such a good feeling, because you can understand that a portion of the network is capable of much more, but we have to accommodate the balance of the network that is still going that could be undergoing an upgrade, change,
Sure.
And so forth. But essentially, the principle was to understand the MAC address capabilities, understand what's currently available, and then work back to determine what is the maximum we can support in the VPLS instance.
Yeah, I do.
That, and on
Hashim, I don't know. I lost a bit of what you said at the very end. I don't know if that was the case with Pablo and Larry as well. So you might have to repeat maybe the last few, 10 seconds of what you said. I lost that audio.
Okay. So I was just concluding to say that essentially you've just got to understand the capabilities, the maximum MAC capabilities, and what resources you have available.
Sure.
And it's work back to understand on your platform that doesn't have, what we can consider as the lowest common denominator, the platform that doesn't have much resources, understand what is the maximum it can deliver per service, and essentially limit the VPLS instance to that. And then offer the capability on a case-by-case basis. So if we have customers, and this is always the scenario, right? I mean, working with product teams, they have an idea of what the product should do, and then you have a customer coming in and saying, we want X, Y, and Z. So that has to be a custom design. We have to go and understand exactly where the customer sites are, where are they connecting to the VPLS instance, and then make that call. And this is essentially how we're going. Just Vishal, if I might add one more thing that come to mind. Sure. As a takeaway, is that VPLS is not an option it's not the ideal option for all customers out there. And sure. I find that it's a challenging thing to work in terms of my sales team or our sales department and our product department, because the price point is lower than taking multiple point-to-point services. We're going to end up in a scenario where customers who actually don't need this buys it to reduce their cost.
Yeah.
Now you find that you end up having to deliver services like this for customers who actually don't have the benefit of it. And this obviously impacts your design and your calculations, because you only understand that, certain customers who really need this capability is going to be buying it, but you find in the marketplace out there, because the price point is 20-30% lower, in our case, positioned as 25 to 30% lower than taking the same quantity of point-to-point services, we have customers moving to that. So this is a challenging thing to work through as engineering.
That's really interesting, because
your product team as well.
So that means your product team and your design team, they have to think really hard about pricing, because this is a very interesting dynamic of customer migration to a service just because of the price, and they don't really need it, but it has a huge impact on the ability of the network to offer those services to the customer that actually need it.
Absolutely.
Wow, that's fascinating. I mean, that's an important takeaway though, because that is something that many other carriers, that are going to be thinking about the same problem, would probably need to think about the economics of how they're going to do this.
I have two questions and I have an observation. My two questions first. The first one is, are the VPLS switches limited in terms of the number of addresses per virtual bridge, or is it per system? In other words, is it limiting me to X thousand MAC addresses for each EVC, or does the system as a whole have a MAC address limit? And then the second question is, do they implement the standard bridge aging algorithm, the standard 5-minute age out? And then I'll give you a chance to react to that, and then I'll make my observation.
Sure. Thank you, Larry. So just on the first question, and if I may just reiterate the question, you want to understand if the system, where do we enforce the MAC limit? And is it enforced at a total system level, or are we enforcing it at a virtual bridge level or a virtual service instance level? And the answer is actually the system itself has only a finite amount of resources, generally limited by your routing engine, your RSP or your routing engine. So this is generally the element or the component of your chassis or your system that you have to consider as a finite MAC capability or MAC limit. However, for the VPLS instance itself, because it is multi-point in nature, and in our scenario, we have limited because of our target market, again, we ended up with a service design of VPLS can only support 6 sites. Each site can only contribute 200 MAC addresses to the VPLS instance, making the total VPLS instance 1,200 MACs. Now we say that because if you look at data center interconnect, if you look at some of the logistics requirements, which generally don't go more than 5 or 6 sites, and if we look at small and medium business enterprises who don't want to connect more than 5 or 6 branches together, this quantity seems to be okay. We enforce this quantity at the virtual instance, at the virtual bridge, and at the virtual switch instance on every provider edge router participating in the VPLS instance. We do it there, and we also do it at the UNI. So we're able to limit at the UNI the MAC addresses coming in the UNI, and on the VPL or the virtual bridge instance on the provider edge router itself, we configure a MAC limit of 1,200, because you could learn MAC addresses, and you will, under default circumstances, you will learn MAC addresses from all the pseudo wires coming in from your other neighbors. So totally, the virtual bridge is given a MAC address limit of 1,200. Okay. In terms of the aging question, does normal aging happen on the virtual bridge? Absolutely yes. The bridge instance, or the virtual bridge instance, or virtual switch instance, by default will have a 300-second MAC age timer. This is important, and I only found it important in one instance. As we were going through our CE 2.0 certification with iMetrics, they ended up having some sort of problems if we kept the MAC aging timer to 300 seconds. We had to increase it because there was some own frames and some multi-point traffic that had to have a longer age out timer in order to function properly between the sites. But this aging timer has a bearing on the VPLS instance, but generally in practice from our test runs, the systems, the clients or the hosts communicating across the VPLS instance are talking all the time. And generally that keeps the MAC address database on the VPLSP is on the bridge instance quite refreshing, quite up to date. So we don't really have a problem with the default MAC aging timer, and we don't see it as a problem either at the moment, if I could say that, Larry.
Okay, that's not surprising. So I guess my primary observation is that that the numbers that you probably need are relatively small, certainly compared to what we see with Ethernet switching, which is where most of my experience is. And one of the areas where you don't have an issue with VPLS is that with an Ethernet switch network, the biggest problem with MAC addresses is in the core, not at the edge. I mean, in theory, an edge switch only has to, over time, learn the addresses that are directly connected and the people that they are communicating with. But the guys in the middle are seeing virtually every address in the network. You don't have that problem. You're really only implementing at the edge. And you know, Ethernet switches that have, you know, a total of say 32,000 addresses for an entire system seem to, in general, work pretty well at the edge. And that's, you know, potentially supporting, you know, hundreds of services. So, you know, I don't, you know, obviously I don't have a number. I mean, if we had a number, this would all be easy. But you know, the idea of supporting a few thousand, 1,000 or a few thousand addresses per virtual bridge instance, you know, doesn't strike me for the vast majority of cases as being problematic. And this is especially true if you're doing data center interconnection, where you know, you're primarily connecting virtual machines together, and they're not coming and going and being created at an enormous rate, like as if you were dealing with an office with PCs. But you know, the bottom line is that it's really a function of what's the characteristic of the customer. I mean, there's no single answer. You could certainly have a customer that has an office with 5,000 PCs in it, talking to some server on the other side of the network, in which case you're going to need to learn 5,000 addresses on that uni, and I don't think there's any magic answer to that.
Absolutely, you're 100% correct.
This is still a great discussion because you know. Go ahead, Hashim. Sorry.
Oh no, I was just saying that Larry is absolutely correct. This is actually a moving target. I mean, it's. But where do you draw the line? I mean, as a carrier, I mean, you've got to have worked out and reduced it to some sort of modeling where it's satisfactory to your network capabilities, and essentially work from there. I mean, introducing a service such as this is quite significant on the network, and if you make the wrong call, you could end up damaging your reputation in terms of bad quality service or so forth. So, I think Larry is 100% correct. This is it's really a magic number that you've got to try and reduce to something of meaning to yourself and your carrier network, and then work your way from there. It's
right. Well, one way they draw the line is simply from a business relationship point of view. I mean, there's a couple of pieces to that. One, of course, is that you could charge for the number of MAC addresses. You know, if the customer wants 2,000 or less, it's a nominal charge, and for every 1,000 more than that, you're going to charge him more. The alternative is simply, you know, let's face it. What's the effect of running out of MAC addresses? The effect of running out of MAC addresses is that you flood. Flooding will use the customer's bandwidth, so the customer ends up paying because his bandwidth is getting used up because he's got too many MAC addresses. And again, he can either cut back on the number of MAC addresses, or he could pay you for more MAC addresses, but eventually he will feel the pain of flooding when he doesn't need it. But you know, that doesn't really hurt you. It eventually hurts the customer, and as long as the customer is aware of the issue and has a way of getting around it by buying more MAC addresses, then you have a solution. But you're right. I mean, it's a moving target.
So, just in the interest of time, I'm going to now transition to the next part. I'll do two things. I was going to talk a little bit about some of the key developments. I'll actually talk about only two, so I can give both you, Larry, and Paolo a chance to address the question that Paolo had raised, which I want to get to because I think that's a very interesting one. But just to introduce a change in pace, we talked about design problems. Let's talk a little bit about sort of business strategy. And in particular, the one article I want to talk about was by Christian Michaud, who is the SVP at Tata Communications. He was talking about telcos and the need for new ideas. And basically his point was, look guys, we're harvesting revenue from the same old services, and we haven't really extended our thinking beyond our core business models. And then he said, well, what do you really need to do that? And of course, we all know the buzzword innovation, change a mindset, something, of course, which is built into the slogan of Metanoia. But he gave 5 things that telcos need to think about, which I think I'd like to quickly talk about. The first thing he said is you got to engage in a cultural change. You got to bring in a DevOps, Facebook-like culture, fail fast, fail forward, experiment, fail, learn, and restart. And you need to adapt in line with customer needs. So that's something telcos traditionally have not been, the fastest at doing. The second he mentioned is developing a partnership model. So again, telcos tend to be kind of monolithic, large companies doing their own thing. And if you're on the small telco side, which is the case with a number of rural carriers here, then you're operating in your own little world, a couple counties, a state, what have you, and you tend to stay away from, in quotes, competition. But what Christian said is that, look, guys, you got to leverage your stakeholders, expertise, partnerships, what have you, and use whatever tools you have in your quiver to develop a more cost-effective telco operation. And then, thankfully, he did say you need also new funding. So you can't really run new initiative, new projects, and develop ideas if you don't have funding to back it. So that's something that you absolutely need. And then to top it all, you need patience. Now, I think you need that both at the engineering level, but really also at the executive management level, because that's where a lot of the problem comes in. If you're answering to Wall Street or its equivalent, and you don't have the patience, if you're a public company, or if you're a private company and you're under pressure from investors, then you have a problem. So you have to give your ideas a chance to get past that phase of disillusionment that is there in Gartner's hype cycle. And as a point of note, when I make the mind map available, which will be clickable, you'll see that there are these references we provided in the mind map. You can actually jump to the Gartner hype cycle and find out what it is. In fact, I encourage you to look at the cycle for emerging technologies from July of 2014, which takes about, I think, 40 or 100 emerging technologies and put all of them on Gartner's hype cycle, including things like SDN and NFV and the Internet of Things and so forth. So that's a fascinating study. And then the last point he said, Christian said, is you got to empower teams with tools. So innovation is, interestingly enough, a learnable skill. It's a learnable mindset. And you have to make the invested in learning things like, let's say, lean organizations, lean management, lean operations, and the like. And he gives some nice references to books that are sort of leaders in that. But the bottom line was that innovation is a change of mindset. It can be both hard and scary, but you got to make the first step. And these are the 5 ways Christian thought telcos can move in that direction. And then right on the flip side is I want to talk about kind of the Internet of Things, which is something I promised in the outline, and take you to a completely different viewpoint about why telcos are not able to get their head around IoT. And we talked a bit about this on the group when Scott Rainovich posted a comment to my article from Christian. And there are 4 reasons that this article gives about why the IoT boat ain't floating for the telcos right now. For one thing, they are used to dealing with pipes. They're used to dealing with demarcation points that kind of stop at the customer, which is pretty much where all the IoT starts. Starts inside the house, connected devices which are talking, connected cars, what have you. Or even if you think about a larger infrastructure, a connected city, they're the endpoints that have to then talk over the network. And the telcos are still getting their head around the fact, guys, am I the network provider? Am I the endpoint provider? Do I provide end-to-end value? What do I really do? So the 4 reasons that are advanced in this article for a telco not looking at IoT, and right after this I'm going to talk about how big the IoT market really is, are these. One is that machine-to-machine communications has slow growth. So vehicle tracking and things like that we've been doing for 10+ years. And apparently the numbers haven't grown as much as they should, although I kind of disagree with that because the numbers that I'm reading from all the analysts are huge, as you'll see in a moment. The other is that the M2M, the machine-to-machine communication ARPU, is 4 to 10x lower than the 3G, 4G broadband ARPU is. Now, I can see why that is. If you're only going to measure your ARPU as providing connectivity between M to M, yeah, obviously it's low because you're using low bandwidth communication. There's really nothing there. But then the value for the operator really has to be beyond that. And that brings me back to my, Christian's idea about telco innovation, that you got to go beyond that, experiment with things that are outside of your comfort zone, scary as they may seem. And then the third reason was that M2M devices are kind of difficult to manage. They have their own sort of protocols of communication, and you have to kind of get your head around that. There's a huge diversity of devices that you need to worry about, but that's all part of the learning cycle. And then the last part, which I think is a critical part, is that the telco is fundamentally unsure of its ability to add value in this environment, which is something we talked about earlier, that they don't know that end-to-end management is a core competency. Connectivity is, the network is, but is end-to-end management a core competency, and should it be one? And that's something that I think telcos as a whole are struggling with, and they're thinking about that. Which then brings me back to the idea of, well, how big is this IoT thing really going to be? And what is IoT all about? So at the bottom, we all kind of know Internet of Things. It's about connecting devices, which could be consumer objects or industrial equipment. And just as a point to note, most of the equipment is actually industrial equipment or healthcare, in the healthcare industry. So we all tend to think of our smart devices and, we got 20 things at home. At the end of the day, that's a small part of the IoT market. But nonetheless, it's an important part because that's the part that you can market to, that the end consumer really sees, and it influences the way you perceive about how you're going to adapt and adopt IoT. So the essential idea is you have these communicating devices, you have to enable information gathering and device management via software to increase efficiencies and thereby enable new services. Okay, that's a lot of mumbo jumbo. So what does that really mean? And why are we even here? So there are two key reasons why we are here in this IoT space and why the space is growing. One is that the cost of connectivity has been decreasing remarkably in the last decade, and the ability to do data analysis, those capabilities and the cost at which you can do data analysis has been increasing remarkably. Just to give you some data points, the sensors, the cost of sensors down 54% in the last 10 years. The cost of bandwidth down 40 times in the last 10 years. The processing cost down 60 times in the last 10 years. So that gives you a sense of why, even if you're going to have billions of devices, and the projected number is anywhere from like 30 billion to 200 billion by the year 2020, that's just 6 years from now, you're going to have, you're going to be able to do that processing because your hardware is reaching that. The other sort of enabler is that the smartphone is really the gateway to the IoT, at least for the end consumer. But remember that most of the IoT is actually industrial IoT, which doesn't really depend on smartphones. But nonetheless, the one that we see is ubiquitous Wi-Fi, smartphones, and as I said earlier, or rather as this article said, I'm simply sort of summarizing it for you guys, is that unstructured data, which can today be analyzed using big data analytics, that's the key enabler. I mean, what are you going to do with all the data with all these devices if you can't analyze it? And there's markets in wearables, in homes, smart cars, smart transportation, smart cities. You can do waste management, energy management, in-building energy management. Of course, we all know about health management with wearables and various kind of monitoring devices. And as I said, the projection is, just to give you a number, 96 to 2015, we had 1 billion fixed internet connections. If you include mobile connections, we are at 6 billion mobile connections. And if you start including the Internet of Things, all these little devices, smart dust, all the way from smart dust to wastewater management, RFID-based tagging systems, we are anywhere, but depending on which analyst company you look at, IDC puts it at 30 billion, Goldman Sachs puts it at, Intel puts it at 200 billion, Cisco puts it at 50 billion. Nonetheless, it's in the tens of billions. So, that's the kind of number we are looking at. Now, the reason I disagree with the previous article, which was giving reasons for why telcos are staying away from IoT, is the following: that at the end of the day, connectivity, the very nature of connectivity has got to change right from the telco perspective, to be able to connect these devices and enable them to talk and communicate in an effective manner. And I'm not going to talk about that aspect of it, but the QoS standardization that I was going to talk about, it kind of ties into that. And I've provided you links, and maybe I'll cover that in a separate, video hangout or a separate video little brief. But the fact is that connectivity changes. And I believe that the telcos need to think, new, in a new way about this, and that's where innovation is going to come in. And the market size, by the way, guys, is in 2014 alone, it's a $180 billion revenue market. And I'm going to provide you some references to infographics that kind of give you these numbers and quote the sources. So you're going to find that in the mind map. And by 2020, the projection is that we're going to reach a 1 trillion revenue market, which is 5 times as much. So that's kind of the scale of what we are looking at in the IoT space. And the reason I wanted to cover that is because, that's just to give you a flavor of while there's a lot of hype, surely we are on the Gartner hype cycle, there are huge numbers to back it up. There are also a lot of different initiatives. If you, for example, the city of Dublin is big on IoT. They're working towards becoming a smart connected city, doing a lot of energy management, waste management, and so on, using smart things. So there are cities like that moving to that. So that's the real thing. It's coming down the pike. And I think it is useful for those forward-looking operators and even the vendors that want to think about it to start integrating, IoT capabilities and IoT management in particular into their offerings. So that's my little soapbox spiel. What I wanted to do next is open it up to any thoughts that you guys have on the couple of things I just spoke about, and then we'll move on to Paolo's questions and to the TCP work that Larry I wanted you to talk to us about. So guys, any thoughts on what I've been talking about in terms of telco mindset and IoT?
Just a quick question. You were saying that the bulk of IoT is industrial, not consumer. Is that in terms of value or number of systems, or both?
It's in terms of the number of systems and in terms of the market share. So the 2020 values, if you split them across domains, I think the consumer segment is like $300 billion of that 1 trillion. 700 billion plus is in the industrial and healthcare segment. And also, if you split it in terms of the global worth of the deployed technology, and I'm still not clear on what global worth means, then by one estimate I saw that by 2025, the technology in devices and healthcare is going to be like $2.5 billion, and in manufacturing, it's going to be $2.3 billion. That's a huge chunk of 2.5 trillion and 2.3 trillion. This is, I think, the whole value of technology. So I think they're including sort of the equipment and everything else that goes around with it. But these are huge numbers, and a significant fraction of the 6.2 trillion of the IoT, global worth of the IoT technology that was projected in that study. So that gives you a sense of how disproportionate the industrial and healthcare segments are.
Right. Thank you.
All right. So what I wanted to do next is go back into our Carrier Ethernet world and address Paolo's question. So Paolo, I'll let you articulate your question, and then we can all try and chip in our thoughts. And just a quick point to anybody that's viewing: if you want to put questions that you might have on any of these topics, then please enter them on that Google group. On the LinkedIn discussion, and we'll pick them up from there. So Paolo.
Yeah, thank you, Vishal. So hope you can hear me properly. So when
fine.
Okay, so when I received the invitation from Vishal, the first question that came to my mind was, well, we are all people used to talk about real technologies, for example, Carrier Ethernet or VPLS, as Hashem discussed earlier. But on the other hand, we are entering, or we are ready to enter an era where virtualization will be key. So in such a new network domain where many functions, many components will be virtualized, does it make sense to talk about Carrier Ethernet, which remains a real technology? Probably this is the case, but if it is so, what will be the role of Carrier Ethernet in such a virtualized world?
So, I mean, I'll give you my sort of 30-second thing and I'll open it up to everybody else. So my thought is that no matter how much you virtualize, Paolo, there is an underlying infrastructure that has still to be, we talked about data center interconnects, we talk about, you know, providing services to an enterprise. That core infrastructure, despite all the virtualization, is likely not going away. Right? At the very minimum, even if we said, okay, everything's moving to the cloud, you still need a huge amount of data center and access and metro infrastructure to at least connect your enterprise and at least connect those data centers to your enterprise, assuming everything's in the cloud. So, and you need advanced technologies to manage, control, and do QoS and various kinds of things on that infrastructure. That's where carrier Ethernet comes in. And if you look at sort of the new initiatives from the MEF, right? NAN's been talking about network as a service, and there's a lot of emphasis that the MEF is putting on sort of controlling the network, the LSO, concepts and so on. They're all designed at making carrier Ethernet or any equivalent technology more useful in this new environment rather than making it redundant in the new environment. I mean, it's never going to be redundant, because unless you have this core infrastructure appropriately working, your applications and everything else on top of it is not going to work. In fact, the QoS topic I was going to talk about, there's an interview by Pascal Menzies, who's the chair of, it's called the International Telecommunications Consortium. Let me just quickly get my notes to see what the name was. But the bottom line was they're talking about how to make applications better talk to the network. And I think technologies like carrier Ethernet and anything enhancements we do to it are essentially fulfilling that role. So I, at least personally, don't see, I see that a larger role. It may be that, there's a lot more talk about the other stuff. There may be fewer practitioners really doing this stuff, but they're going to be having a much larger role building this infrastructure. I mean, that's my 1 minute take on it. But, Hashim, Larry, I mean, these are the other experts. Let's see what they think.
Well, I guess my opinion is more or less in sync with what Vishal just said. I don't think the question is what's the role of carrier Ethernet in the virtualized world. I think it would be better questioning what role does virtualization have in the carrier Ethernet network. The network itself and the function of the network is transport from point to point, and you can't virtualize that beyond some point. I mean, you still need to be able to carry bits from point A to point B. But the carrier Ethernet network does have a number of computational functions. There are NID functions. There's the CE function. The carrier, the customer edge could eventually be a virtual device of some sort. The UniN, where you're entering the network, has a number of functions. For example, policing, and does it make sense to have the concept of a policer as a VNF, for example? That might make no sense at all. But I think that the whole focus of NFV is looking at functional entities like a policer or like a shaper or like a firewall or like a pick your favorite function and determine whether that could be virtualized. And I think in the context of CE, there are probably a number of components of the CE network, of the carrier Ethernet network, that are potentially virtualizable. I can't tell you, I mean, I'm not an expert in virtualization, so I can't sort of say, here's what I think ought to happen, but certainly people are talking about virtualized NIDs, for example. A number of functions like that could certainly be virtualized. But I don't think the CE network itself becomes moot in an NFV kind of situation.
Yeah, go ahead, Paulo. Hashim, your thoughts? You're muted, Hashim, for some reason. Hang on. I don't know if I ended up doing that. No, I don't think so. Can you just double check?
Yeah, I think I'm back on. If I really listen to Paulo's question, his question was regards to, in a world that's moving to virtualization, will there be a place for carrier Ethernet as a real technology? So I think that is the question that came from Paulo. And if I think about it, I mean, Carry Ethernet is not in itself a technology, it's actually a service. So as Larry nailed it on the head, I mean, you cannot virtualize beyond a point. There still has to be real equipment or real technology that moves bits from one place to another place. But if I had to think about Paula's question, virtualization will happen, yes, but one of the results as a service from virtualization will also be carry Ethernet. So if you're applying virtualization in an environment like a network, one of the services that will be an output of that is going to be carry Ethernet services. So I can't really put my point across in terms of where carry Ethernet as a technology and how it's going to play a role. I feel it's going to be more a result, from my opinion. Yeah.
Actually, it's a bit of both, right, Hashim? Because I mean, even the MEF defines it both as a technology and as a service. So the services component, of course, will be there no matter what our infrastructure is. But if we think about it as a technology, as a combination of all of the various pieces, and we talk about VPLS, or we talk about IPMGLS, or PVB, or PNP, whatever, QNQ, whatever we want to call it. If we think about those technologies that actually help to realize the service, I mean, my feeling is that that role is not going to go away. If anything, I think that the virtualization guys and the sort of network infrastructure guys are going to have to talk more to make all of this work. I mean, right now we see a big divide. There's a lot of activity in one area, and it seems there's not so much activity in the traditional areas. But I think that cannot be a sustainable model. You're going to have to talk much more to make all of this infrastructure work. So if anything, I think it's going to have a larger role, because people in the virtualization world will have to understand better how to use carry Ethernet. And the carry Ethernet guys will have to understand the requirements that come from virtualization and the applications and the new applications, so that they can architect a better carry Ethernet service. I mean, you can't just have a limit on MAC addresses like we have today that we talked about earlier on, and and then hope that you can build a hugely scalable IoT service connecting billions of devices, right? That's not going to work. So some innovation has to come there somehow.
Actually, the other point is that in a sense, virtualization, and I think this might be what Hashim was getting to, virtualization actually creates a requirement for carrier Ethernet, because you basically have to be able to get to the VNFs. You need to be able to get from the source of the data to the virtualized the function that's being virtualized on some service somewhere. So one could argue that actually could be another application for an Ethernet service. So
Paulo, your thoughts?
Well, actually, I agree with what we have been discussed so far. You, Vishal, pinpointed something that I agree upon. So, carrier Ethernet can be seen as a technology.
We just lost your video for some reason. I don't know why, but.
Oh, let me check.
No, I see. I see him just fine.
Okay. So somehow I'm not seeing it, but that's all right. As long as everybody else is seeing it, we're good. Go ahead, please.
Yeah, no problem. So just a 30 seconds thought. I was saying, I agree with your statement that carrier Ethernet can be seen from a technology perspective and from, let's say, a service perspective. So it is both, actually. What I think is that the technology layer probably will be commoditized. So we will have, carrier Ethernet pipes handled by the service layer, which is where the intelligence will stay. Probably that is the layer that will be virtualized through the new domains, new components that we are seeing entering the network, SDN controller, virtual components, whatever. So basically, I completely share the view.
Okay, that's great. I mean, obviously this is an evolving point, and I'm sure there'll be other viewpoints. And once we post the video of this and we have some other discussion in the group, I'm sure there'll be people on both sides of the aisle, and I'll look forward to kind of hearing other opinions as to how this is all going to shape up. What I wanted to do now is, Larry, I will defer anything else that I was going to talk about. I'll create a separate video. There were two other topics on net neutrality and so on, which I do want to get across to the audience. But I think while we have all of you guys here, maybe what I want to do was take a moment and give Larry an opportunity to talk about some of the TCP/IP interactions with traffic management that we talked about in a couple of other very interesting discussions on the group, which are, by the way, linked to the mind map from the previous Carrier Ethernet Live. And if you haven't gotten it, you should please write to me, and we'll make sure you get that. But the basic point there was, we were talking about how does a policer impact traffic, and how are some of the parameters of the policer decided relative to the fact that you are sometimes carrying TCP/IP traffic. And Larry, I'll let you carry on and talk about what you had mentioned, the key highlights of sort of the interaction between TCP and the policers, and what we are discovering about it as we delve more into simulating that.
Sure. Before we do that, though, you want to push that off until your next hangout, given that we've used up the hour, or do you want to take the time now?
It's really your call. I mean, I don't know how much time. If you need maybe 10-15 minutes, then we can push it off to a future hangout, or we can do it as a separate video, and which we can link to this one. That's certainly a possibility. Because this already, we are at an hour. We did spend time in talking about some of the other things like VPS.
Yeah, I mean, I could go either way. If you want to do another hangout next week, I'd be happy to do it next week. If you want to extend this by 10 or 15 minutes, we can do that also.
Let's just go ahead and do it, since I had promised the people that. Okay. We can always split it into 2 videos or whatever, because most of the people are going to watch it post facto, so that's all right. Let's at least get some of the discussion in there, because it ties in very well to what we did last time, and I'd already requested you to do that. And again, we can always continue it at a future hangout and a future video.
Sure. So the issue at hand is configuring policers. That's really what this comes down to. Eric Tim asked the question whether there were any standards for CBS. Clearly you don't need standards for the information rate like CIR, because that's the amount of bandwidth you're selling to the customer. So that's sort of an easy one. But CIS is much more difficult, because it is more focused on the operation of how the policer works, as opposed to just limiting something that the customer is doing. And the answer is that today there are no standards for CBS. That the need for CBS is really a function of what's happening in the network. The Class of Service Implementation Agreement Group, MEF 23, is actually actively working on guidelines for CBS. However, they're working on an update to that spec 23.2, and ironically, the call I was on just before this one was the weekly COS-IA call, where CBS in fact was today's topic. It's a big topic, and to some extent it amazes me that it's still a big topic. I mean, we've been doing policing with the token bucket policer for a long time, and the problems that are just beginning to see daylight are problems that people have actually been having for a while, yet nobody really formalized it. But I was tripping across these problems 2 or 3 years ago with customers, which is what started causing me to dive into it, and I brought those up to the cost group, and Steve Haddock and the cost group really took off and has added a huge amount of value to that. The issue is as follows. The CBS in a token bucket implementation effectively defines your burst tolerance. It's how much traffic you can send at line rate, because and this is actually another thread that's on the Carrier Ethernet group, because CIR isn't an instantaneous value. It's really an average. The Ethernet pipe operates at the Ethernet speed. If it's a gigabit uni, the packets are arriving at a gigabit per second, even if you've sold the customer, say, 100 megabits CIR. So the question, CIR can't be an instantaneous value. It's got to be, okay, I'm selling the person 10% of the pipe. What that really means is that on average, I'm expecting him to send packets with sufficient spacing that the total value or the total amount of bandwidth used by those packets will be roughly 10% of the pipe. So the question is, what's the averaging time, and how is all of that computed? And the burst bucket is the mechanism. And what it does is it basically gives you a license. I always say it this way: gives you the license to transmit at line rate for up to some period of time, and then you have to stop to replenish the bucket. And that stopping period is the thing that causes the average to end up being CIR. The problem is that whereas for many kinds of traffic that works great, for TCP traffic, it has been seen over the years now that the performance of a TCP session running over a policed Ethernet circuit, Ethernet service, is far below CIR. If you run an FTP session between two stations connected by 100 megabit Ethernet, you see something close to 100 megabits per second eventually for that file transfer. If you run an FTP between two stations that are connected by 100 megabit Ethernet service, but the two stations are on gigabit Ethernet links, you see a much, much lower rate of traffic. And the problem turns out to be that there's a really bad interaction between the adaptive congestion control that TCP does and also the congestion avoidance that TCP does, and the policer. And effectively what happens is that you end up with this boom or bust cycle where TCP will continually increase its window, which is what TCP does until it hits a limit. Now, because I have a gigabit link, it doesn't actually hit the limit until it gets to a gigabit, which could be much faster than my CIR. So what I end up doing is completely depleting my CBS bucket, at which point the effective bandwidth of the circuit goes to 0. And TCP doesn't expect bandwidth to go to 0. It expects fluctuations, but it doesn't expect a gigabit and then 0, and then a gigabit and then 0. And the problem is that it doesn't do the congestion avoidance correctly, and you end up just doing a timeout every time the bucket depletes, which could be like a quarter of a second. So what you effectively end up with is one CBS amount of data every timeout period. And if the timeout period is a quarter of a second, that could be a relatively small amount of data. So I can show you some slides if I can figure out how to do this. Give me a second.
So Larry, you just need to press the screen share button, and it'll give you a choice of windows to use. And if you have that window open, you'll see that in that menu choice, and you can just select that. And then we should all be seeing that.
Okay, let me find the one with the slide. Here it is. Can you see that?
Yeah, we are seeing that now.
Okay, so
it's not in slideshow mode, but we are seeing exactly what you're seeing.
So this is
the slides on the left-hand side and the main window in the middle. Maybe you want to put it in slideshow mode so the window will expand.
No, the problem is that goes to my other monitor.
Oh, don't worry about that then. I have solved this problem, but let's not solve it here. Let's just continue.
I'll try to make this a little bit bigger, though.
Yeah, that's good.
This is from Steve Haddock's presentation. So the gray line is what you would expect if your data was actually happening at CIR rate. For example, if I was connected back to back on 10 meg, this is a 10 meg CIR on a 10 meg link, and what you actually see is something that looks like this blue line. You're getting something like 2% of the line rate over time with a CBS of 29K, which is basically the window size. And your first belief is, well, if I create a CBS that's the TCP window size, I should be able to get good throughput. And the answer is you don't. What you need to do is actually set TCP, CBS, to the window size plus the amount of CIR that you would need during a timeout, the TCP timeout window, which, like I said, is usually something like 200 milliseconds or a quarter of a second. And now, as you can see, what happens is you get a burst of traffic, and then you get none for a while. But now you're averaging it down to the CIR. So you get a burst greater than CIR because you have this huge CBS, which is giving you the license to transmit at line rate, and then you deplete the bucket, and you have to stop for a timeout period. But that gets you back down to CIR. That's what it means for CIR to be an average. And you can see in this case, you end up with a rate that approaches CIR. But now you're talking about, in this case, a very large window, 274 kilobytes for a 10 megabit per second connection. If you're talking about a 100 megabit per second connection, then you're talking about something like 2.7 megabytes. There are lots of problems with having really big CIRs. Let me turn screen share off. That Vishal has been talking about in some of his videos, but the two basic problems are that you're basically, with a large CIR, imagine a 2 or 3 or 5 megabyte CIR. You're allowing...
You mean CBS, I think.
CBS, excuse me. You're allowing every customer that has that to burst at that rate. Now, assuming the worst case, and that many of them end up bursting at the same time, then what you end up with is this huge influx of data into your system. And one of two things will happen. Either it will overwhelm the uplink, even if that uplink is undersubscribed. You could have 2,400 100 megabit per second circuits going into a 10 meg uplink. So in theory, you're only subscribing that 10 meg uplink by 25%, which is well less than most service providers will subscribe an uplink. But even with a 25% subscription, if all 24 of those could burst 5 megabytes into the system at the same time, you're getting 120 megabytes of data into the system in the time that you can only transfer about 50 megabytes out on the uplink, which means you need to buffer all of that data. Most access switches can't, and therefore you effectively are dropping green traffic because these were all going to be declared green by the policer. The alternative is, let's say you could buffer it. Now what you have to do is calculate the delay experienced by the packet at the end of the queue of 200 megabytes of data. Either way, it doesn't work. So the problem is that building big CBSs is not the solution to the problem. What Steve has shown in his simulations, and I don't want to use up a lot of time, so maybe we can do this another time, is that if the CE, if the customer equipment shapes into the policer with the appropriate shaping parameters, or for example, if the carrier puts a NID at the customer premises that shapes for the customer, which is a more likely situation, really, then you actually get reasonable TCP performance with a reasonable CBS, because effectively what the shaper is doing is increasing the delay. The problem is that the policer limits the bandwidth without increasing delay, and TCP adapts to delay in the network. What the shaper does by spacing packets out going into the carrier Ethernet equipment is it increases the delay of the circuit from a TCP point of view, so that TCP will then adjust itself down to the actual CIR, because now you're seeing a delay that's consistent with the CIR of the circuit. So that takes more analysis. I don't think we want to do that right now, but that's basically the summary of what the problem is all about.
So Larry, now I know why you're a great teacher, because what you just explained in the last 2-3 minutes finally made it clear to me why the shaper was actually, what exactly the shaper is doing. I mean, I kind of sort of knew it, but that spacing out of the packets and how you TCP, really adjust to CIR. I mean, that explanation is fantastic. So thank you so much for doing that for us. So with this, I wanted to thank every one of you for coming on and doing this hangout. I know it's an important investment of time. I really very deeply appreciate your doing that, and I hope that the people who viewed it and those that are going to view it subsequently, it's there for posterity forever, pretty much, are going to appreciate the knowledge and the insights that have been shared here from a design perspective, from where technology is going, to the analysis of TCP and Paolo's question about virtualization. So once again, guys, thank you very, very much for being here. I really appreciate it.
Okay. Thanks for having it, Vishal. Bye-bye.
All right, and then as I always say, may the bits in your bytes and the bytes in your packets be profitable. We'll see you next time.
Thank you.
Thank you.
Bye-bye.
Bye-bye.
Bye-bye.